Hello, everybody. My name is Ray Katz, and I'm a Principal Solution Engineer at Couchbase. This session would be about securing your Couchbase deployment recorded in Zoom for virtual presentation. We will speak in the next 30 minutes about various subjects, but all in all, we will speak about security and how to keep your deployment more secure by doing a few simple steps. We will discuss risks and how Couchbase answers them. Of course, there is a lot to cover and we can't cover it all in this session. But I hope that you will end this session with more awareness and knowledge and how to start looking for a safer deployment. But first of all, who am I? So my name is Ray Katz, as I already mentioned, a Principal Solution Engineer in Couchbase for the past 5 years. I saw Couchbase growing from a mainly KV-oriented NoSQL database to a more general-purpose one, a growth that has impact on everything, from usability to security considerations and concerns. Before I've been to Couchbase, I've been a developer, and as such, I personally know that sometimes security is something that you think of after the fact, but, well, it's being thought on. But when you build a system, you can develop everything, you develop your infrastructure, architecture, and sometimes security is left apart of the main considerations. In today's world, with the cloud deployments, you should take security measures first as part of any architecture. And I'm here in this session, we'll try to convince you about it, or mainly basically try to make it more simple for you. Before we begin, I would like to mention that I can't speak about Couchbase security in a vacuum. I will need you to have a bit of knowledge in Couchbase server, a basic knowledge about certificates, and to feel Couchbase comfortable with code, at least in the very basic level. I will show here SQL code, and I will show here some Java code, very few lines, so just feel comfortable with that. We will focus here about four major risks that usually are the lower hanging fruit and easy to achieve. Also, as a bonus, they are the most critical ones, from my understanding at least, and applying those will definitely secure your system empirically. So let's talk about the first risk, passwords. Now, this is the easiest thing to implement in any system because any system has password and you need to choose the password for any system. And also enforcing password policies is something that every system have. I can't help but mention that I saw many times that the default password, username password, is actually left out, and many systems still have, well, Couchbase as a username password, administrator password, or just administrator and password administrator. This is the gateway to your system and you should protect it. And this is like a major risk and very easy to resolve because, well, any system, even the one that tries to be compliant with ISO 27001 2013, for example, will fail if the weakest link, like a username and password in the system, is being left out and nobody deals with that. I don't have to tell you how many times password lists and hashes are being emitted and dumped to the web each year, and how easy it like to brute force that. Well, you probably heard about new GPUs, maybe you don't, but be familiar with RTX 3090 and 3080, which is like the king of GPUs today. They can actually hack and guess billions of hashes per second. And more precisely, if they're very short, they can do it very efficiently. even if it's like rainbow tables, dictionary attacks, whatever you want, like substitutions. They have a lot of tools built in for them. For example, if you look for Hashcat, you will find that it's even a publicly available software, very small one actually. If you add to that like social engineering, for example, the name of your dog, let's call it Rexy, or and the year of your birth, if you choose the password that actually named Rexy 1975, well, you're as exposed almost as someone that haven't chose a password. It's a very easy password to crack, and I will not recommend on any such passwords. And now I'm not here to scare you, but given that the many people tend to reuse the passwords, even the most efficient and highly sophisticated cyber company will be compromised when somebody is choosing a simple thing like a password. You make the life of the hackers very, very easy. And it doesn't matter what I will show next, if it's encryption, if it's anything, it doesn't really matter because you already compromised the system. So let me define some ground rules. Rule number one, never ever reuse the database password in any other system. It's actually true for other things like your Gmail password, for example, or any other email password. Don't ever use it in other places because once they are emitted to the web and somebody guessed it, he guessed everything that you have. And people also use the email for everything almost. And if you reuse your password, you probably are compromised already. Rule number two, practically, if you use a short password, you're being compromised easy, easily. Okay, so I actually urge you to use the long password, at least 12 characters. Um, when doing so, practically, you you make your security better. And not only doing that, but if you add also uppercase, lowercase, some kind of symbols and digit, you increase the complexity and the difficulty of the hashes and guesses tremendously. Number three is never use dictionary words. Like, for example, don't use even complicated dictionary words because they're already compromised. Even if you use, like, let's say, microphone, headphones, camera, or thing that you see around you, well, people already know those and they try to implicate those words on your password and try to guess the hashes because I said hashes a couple of times, but basically it's taking your password, do some calculation on it, and get a number. And if they have this number, they can match it, your password, to what already happened, what already been dumped to the web. And if they match those, they have your password basically. Hash is a like one password. Hash is like a unidirectional function that takes the data from one side and emit a number or a series of results on the other side. And for each actually one password, there is one hash. So it's very not easy, but it's possible to calculate those. Rule number four is actually use a password manager. I can't actually um, emphasize this more, but it's actually applies all the best practices that you can imagine on, and it's very easy to remember one password, one strong password, and let the password manager to do the rest. Now, of course, there are more things that I can speak about. It's a never-ending race, but I think those rules are very self-explanatory, and if basically you follow those, it's going to be much harder to guess your password and to guess, like, to crack your system. The second risk I would like to discuss here about is about the man-in-the-middle attack. Man-in-the-middle attack is like, think of it that somebody, for example, this man in this mask here, is practically sniffing your data and taking it out. Maybe it's harmless, maybe it's not. Usually it's not very harmless, but well, it happens. And you don't want to keep the data from your servers to the web unsecured. And we will learn how to do so very easily, actually. But this is the major risk that people don't really understand and keep the communication between their app server to Couchbase server practically, well, exposed. And this is actually not a matter of password or choosing the right password. Is like assuming that the password are absolutely fine. Still, if the data is being transferred over the web without any guards, it's gonna be, well, it's gonna be attacked. It's gonna be taken. Somebody gonna use it. The next risk is, well, it's more of a risk of abuse of things. If people have the power, some people will abuse it, but no doubt, it's the human factor in security. So imagine the following scenario, and I'm not trying to actually say that those are bad, but think of a developer that have access to a production for legitimate work. You have access to a bucket. A bucket is like a Couchbase database. And you have it for a well-defined amount of time. But let's think of it like somebody forgot to revoke his permissions. Now, well, maybe we'll do nothing, but like the first thing in security, don't ever give permission to somebody that doesn't need it. If this person don't need the security privileges, revoke it. It can lead to actually illegitimate privileges abuses. And practically, this is the most difficult of all to track. Because he might have everything. You have like the right password, your everything is encrypted, but well, you still have the power to do anything to your system. For example, querying your bucket or querying a bucket that doesn't belong to him. Look for medical records if it's a medical company and read some user data that might be very, very sensitive. So those are the questions we need to ask. The fourth risk is actually about SQL injection, or how we call it in Couchbase, nickel injection. Might be a thing. It's the same language. It might have the same risks. So think of it like, if you look at the first one, the first query. The first query is something that is very simple. Give me all the breweries from a bucket called beer sample. Give me all the data, but only of the breweries. Somebody attacked me, and what I got is like the same one, what with the ending of 1 equals 1, which actually means that I will get all the data back from this kind of query, which is a bad thing to do. And we will learn today how to actually save yourself from those risks. So let's summarize the security risk and proceed to how we deal with them on Couchbase. The first risk is a bad password. Second is man-in-the-middle attack. Third is a privileges abuse, and the third is SQL or nickel injection. All of those gonna leave your system exposed and gonna lead your system to be, the database to be vulnerable, and we want to avoid those. So what's Couchbase answers to those risks? The first thing is basically, how do we fight bad passwords, right? Other than just using a password manager, which is a must-have from my opinion, um, we provide a complex but intuitive user management. You can access it by the admin web UI over here with the security tab, and then see the user and groups tab on the top. The web console In the web console, you can create users, you can assign roles, you can delete the user, you can actually reset passwords. You can see if the user is internal or external users, and you can actually also assign groups and define LDAP system if you need to. Well, you should have, and we'll discuss it in a bit. The internal user actually are securely securely kept and hashed and salted properly, so it will not be so easy to actually steal your data or steal your users. Now, we also provide out-of-the-box password management for the internal users. So even if you don't let any other system to control your users, you can still be secured with more than a simple password. You can have you can have control on the minimum length of the password. If it's like have to have uppercase, lowercase, digit, and special characters, as I mentioned before, when you have more complex password, it's more difficult to guess even with the best hardware. So practically, it's something that you should enforce when you use only the internally stored Couchbase users. For anybody that wants a bit of more control over the users, we actually recommend to integrate with LDAP. LDAP integration is native to Couchbase and is the easiest solution for enforcing usernames, password rollups and resets and credentials that are meeting the standard of the organization. And actually, it's managed in centralized, very enforced, very secure place. And I recommend everybody to just use LDAP if they can, or any Active Directory actually. Everything that controls your password is blessed, because then you're gonna have one password that practically combined is joined by many services, but it's not like password reuse. It's more of a password, the real password security thing, because it's a one place. Now, what you can see here is a screenshot of my LDAP configuration from my cluster. And what you can see here is the following. This is just a basic page, but you can see the IP. This can be a host name, but the IP of the LDAP. You can see here the port of the LDAP. You can see here that it's like 363.636 port, which is the secured LDAP port. If it says 389, you should understand that it's probably unsecured, because those are the conventions in the LDAP. You can also see here that the connection is encrypted, and you can specify certificate for authenticating this connection. I didn't specify one. Also, we provide various way of connecting to the LDAP. Here I chose the credentials with the password, but you can also assign the client certificate if you want to connect to Google AD or something similar. You can see the the domain name of the LDAP, and once you check your settings and all good, you can enable LDAP and user authentication, and you can start using LDAP. It's very easy to set up. It's one configuration that fits all, and basically all you need to do is just to know what you left to do is to assign your roles to the users you just authenticated using LDAP. You can also you can sync groups from LDAP and make your management much easier, because you probably already have like a DB admin group, developer group, and others. You sync those up to Couchbase and you can use it as your own groups. So the first risk was about passwords. The next one is about the man-in-the-middle attack. This is our second risk. In order to deal with the man-in-the-middle attack, or well, maybe just a curious person, we need to provide some kind of encryption over the wire. We have a lot of wires to cover, and we provide guarantees to all. Whether if it's like client to the server, whether it's server to server, or well, maybe just the disk, we got you covered here. So what we actually provide in terms of security, in terms of encryption over the wire. Um, I will state them in some kind of my order of severity. So the first one would be the SSL transport from the client to the server. This is the most important one because all the data, actually, the new data is being transferred here. And well, not all time, but sometimes it's actually runs over the internet. Actually, it's most cases, it's run through the internet and you don't want to leave it exposed. The next one is also very important. It's very similar to a client one, and just using like from Couchbase to the other client or other Couchbase with our own protocol of XDCR. XDCR is a cross data center replication, and we don't want the data that being transferred from one cluster to another to be exposed. So we can encrypt it just like any other client. The third part is actually enforcing more security on top of the client and ditching the password authentication in favor of X509 certificates. It's going to reduce the risk because right now you're using a pre-signed certificate to actually authenticate your user to the client, to the cluster. I won't get into details here about 509 certificate, but just another certificate that comes into the process of securing your connection with TLS. The next bit is actually the last part of over-the-wire encryption is node-to-node encryption. Node-to-node encryption encrypts all the data from one server to another and between services. It's practically have two kind of methods: encrypts all the control data or encrypts all the data itself, one on top of the other. The last piece is not actually over the wire, but is also very important, is data at rest encryption. We provide support to it through LUKS in Linux or via third party, like, for example, Wallmetrics. It's important as, well, if somebody get a hold of your data or the disk or make a snapshot of it, they practically can't do anything with it as it's rendered useless. So this is in theory. Let's see an example in Java. Um, well, as I said, I was a developer. I'm still trying to be as hands-on as possible. Um, so let's see something how we do it in Java. But first of all, let me explain what you see here. So if you go to Security tab and then Root Certificate, so let me explain what we see here. We see here under Security and Root Certificate, the cluster certificate. You can see here that the common name of this certificate is Couchbase CA. It's expired in 2029, and this is the public part of the certificate. Practically, certificates are part of a PKI or public key infrastructure. And well, I will not actually explain that here because it's practically out of scope how to handle and how to actually set those certificates up. I recommend you to continue and do a further reading about Diffie-Hellman Key Exchange and the PKI and public CA and root certificates. Now, once you take this certificate and add it to some kind of a repository, usually it's some kind of CA, okay? As you can see here, it's a CA. When you have it, it's very easy to manage, and let's assume you already have everything and everything is set it up. You just take this certificate, which can be either out of the box certificate that we provide with Couchbase, or something that you have your own. Take it and just paste it to some file. Let's call it cluster cert. And then from your code, which looks like that in SDK 3 of Java, you can enable TLS and just point the code to a certificate. All of those going to be in the cluster environment settings. It's very easy, and what actually is doing, it's negotiating its way from the SDK to the cluster, and will create secure TLS tunnel. So all the data that's being connected to Couchbase is actually secured. Now, this is very easy, as you can see here. Just copy and paste it to a cluster cert and point the certificate SDK. But what if you want to actually further enhance the security of that client, as we said before? Well, you actually enable that in the UI. In the same security piece here that we saw here, you can click on client certificate and you will get this screen. Enable the client certificate and either do enable or mandatory. When you do it mandatory, you can't actually use username and password. You just need to use certificate and put the subject CN that will contain the username. By the way, if you can do it by UI, you can do it by REST or by client CLI. And once you enable all that and you ask from your system administrator the client certificate, and well, all you have left to do is to enable that, to point the SDK to those certificate and just enable that, and your cluster, your SDK will know how to communicate with this certificate to the cluster. It's just like another piece of the puzzle. If you want to have a further question about how to set up those certificates, you're welcome to ask me any questions via email that I will share in the end, or with any other method. Now, we secure the SDK. Let's now secure the XDCR. Again, as I said before, XDCR is just like another simple client. No, not a simple client, but it's just another client. So if you add a remote cluster reference in the UI, you will see this page. You specify the local name, the local reference, just the name. You specify the IP or the host name, username, password, click on Enable Secure Connection, and put a certificate. Just like we saw before, you just need to add the certificate of the other cluster. Just like you do in the SDK, you took the certificate from one cluster and put it in the SDK. Here you think of the XDCR reference as your SDK. So you need to take the certificate from the other cluster and paste it here. But notice that still we have, well, username and password. If you want to bypass that, just like before, you need to ask your administrator to get you a client certificate for the other cluster this time. Paste here the public part of the certificate, and here the private part of the certificate, and ditch the username and password, and you're all set. You just click save, and if you set up the certificate correctly, you will have a very secured XDCR connection all across the board. Now, well, the next bit is about actually securing your traffic internally inside the cluster. How do you do that? Well, in order to do that, you need to enable the node-to-node encryption. And assuming that you set up all the certificates right, like in your deployment, all you need to do is do two simple, actually, commands. One command is to enable node-to-node encryption, which will enable only the control plane encryption. Control plane is all the commands that Couchbase is sending in order to communicate with the other nodes, cluster manager, and others. And then you will need to actually turn it on to the data plane. The data plane is practically the other piece which enables it to all levels, all data security will be secured after you enable that. Couchbase CLI, setting security, look that it's a different kind of tag, and you just need to say all levels are being secured. Now you will see in the UI this piece that encryption is on, and well, all traffic is from now on is secured. You just need to make sure that when you add a new node later on, or maybe change nodes, you will need to actually move the certificate from that node to that node and enable that encryption. Now, for the next piece is basically avoiding the permissions or managing permissions, which help us to mitigate the other piece of like abusing the permissions. You need to limit the permission in order to avoid some people to actually abuse them. It's limiting everything. You can use it by the UI. We have a nice and very granular UI that you can choose which permission you need to actually allow here. You can do it by nickel, just a grant or revoke role like in normal databases. Here it has like a data reader permission for the entire buckets, for all buckets, to user called users. And you can do it also from Couchbase CLI. We said that everything you do in the UI, you can do it from the CLI and from REST. So it's true for here as well. Everything you do here basically translate to a REST command. And Couchbase CLI is an wrapper on top of the REST command here. The next piece is actually understanding if a person is doing something wrong, because he's not going to tell you. For that, we have audits. The audits log actually, it's like a crumb trail of everything that the user did or everybody did. And it logs who did something, from where he did it, when he did it, and what he did. And basically, you can take this convenient JSON and transform it to any other thing. Like, for example, you can transform it to syslog, right? Now, practically, yes, it's nice that you can convert it to many formats, but how to enable that? So it's very easy from the UI. As I said before, if you have a UI for that, you have a REST API for that. So you just enable the auditing here, specify a folder that you want to save those logs in, specify some settings, and enable that. But I will need to warn you that don't turn it on to an applicative users, as practically if you enable it for reading data, for example, you will get spammed, as application tend to read data much more than just the normal users. Also, it's the point maybe to share with you that never reuse the username like of the application to any other piece. For example, never use the username for the application to administrator Couchbase. Okay, Couchbase administrator should have one username and password, and applications even can have multiple username and passwords. Now, for the last piece, the last security threat risk, actually, I would like to speak about SQL injection, nickel injection. Our language is very powerful, but as SQL is susceptible to maybe some kind of mischiefs. Take this query, for example, that you want to actually query where type equals beer, type brewery, and style equals American style. Well, you don't want to use that. You want to use parameterized queries. Why? First of all, it's much more easy to hack, much more difficult to hack. When you use parameters, it's actually being validated after the fact, and things like expression can be inside those kind of inside those kind of parameters. So if you use parameters, not only you being more secured, but practically um, practically you actually making the database work less, because the execution plan would be the same for this query, and each type you change here would be different. So the plan would be multiple planes, multiple plans, except here it's gonna be one. So let's summarize, okay? We had four risks, right? We have bad password, we had man in the middle attack, we had um, the abusive of permission, and we had the SQL injection, nickel injection. So for passwords, we have password management. We have LDAP, you have user management. We can do groups. Basically, manage everything in order the risk of bad password will go away. This is the easiest thing to actually manage. You don't need to do anything almost. Just keep track of the passwords. Force users to have better passwords. The second one is end-to-end encryption. Well, client to server, server to client actually, between the node and between the servers with XDCR, encrypt everything you can if you need so. Keep your data safe at your hands. For the next risk, we have RBAC and auditing. Just take control, take ownership of what happens in your system. Limit your users. Well, not as they can do their job, but limit them to what they need to do and what they need to know under the least permissive RBAC settings. Audit the system, push it to a third party maybe, or just examine it yourself. Take ownership of what belongs to you and secure the system. And the last one is parameterized queries. Well, build your queries as such as they are not susceptible to kind of an injection attacks. Okay, all of those gonna help your system to be much more secure. And this is even not even with discussing on the VPCs, another part of maybe private networks the cloud provider will give you. This is a totally different part. um, if you have any questions to me, please ask me. My email is set here. You can send me any mail that you want about what was shown here or not shown here, maybe, because there is so much ground to cover. 30 minutes might not be enough for that. And thank you, and I hope that you enjoyed this session.